Problem 3. Here we're going to graph exponential curves. Both of these are based on 2 as your base, and I know that y equals 2 to the x starts flat against the x-axis, rises through the point 0, 1, and then starts to rise quite quickly. Every time you go over 1 unit, the height is going to double. Now I have to see what happens with these transformations. When I graph exponential curves, I start by looking at what is on the outside, in this case the +1. That is going to lift the entire graph up 1. So instead of flattening towards the x-axis, that's the line y equals 0, it's going to flatten towards the line y equals 1. Next, I plot the point that's going to be similar to this point, the point for which the exponent is 0. The exponent is going to be 0 when x is equal to 3. So I move over 3. If x is 3, that's 2 to the 0, which is 1, and 1 plus 1 is 2. I haven't attached a negative to the x, so I still expect exponential growth, though if you'd like, you can try another point. For example, if you let x equal 0, you would have 2 to the negative 3 plus 1. 2 to the negative 3 is going to be 1/8, so I'd be at just 1 and 1/8. I'll draw my exponential curve, starting flat against y equals 1, and then slowly rising up to this point. I'll label it as the point 3, 2, and then it's going to start rising markedly. The next graph is highly similar, and we graph it in much the same style. I start by going up 3, 1, 2, 3, and that will be my horizontal asymptote. I'll label it y equals 3. The exponent will be 0 when x is 1. If I plug in 1, I have 2 to the 0, that's 1, plus 3 is 4. So this should go through the point 1, 4. Now, this time, there is a negative attached to the x, so I'm expecting exponential decay. One easy thing to do, since we're so close to the y-axis, is to plug in x equals 0. If x is 0, I have 2 to the first, that's 2. 2 plus 3 is 5, so I will go through the point 0, 5. Now I can graph it, exponential decay. It's going to swoop down, go through these 2 points, and flatten. I like labeling this point, the point that is most similar to the point 0, 1, the point for which the exponent is going to be 0, and that is the point 1, 4.